So class, we're going to describe the long-term trend of this data, which is marriages in New Zealand. We've just had a discussion about whether I should break this up into 1, 2 or 3 components. We decided that we'd do one component to start with and then maybe break it down and talk about this increase, which is different to the general trend. So using pen and paper, I print the graph out, I draw a best fit line on the trend line, which is the blue line, and I need to look at rise over run. The run I can tell is 1980 through to 2015, which is 35 years. So that's my horizontal component. My vertical component, I need a ruler, and I need to parallel it with another line. Maybe actually, I'm going to get it right to this point here of the line. So delete that line there. And I can see where this line cuts this axis. So I've got 23,000, I'm going to say 23,500 all the way down to 19,500. So I'm calling that 19.5 and this 23.5. 19.5, 20.5, 21.5, 22.5, 23.5. That's 4,000 marriages declined over 35 years. Rise divided by the run. So literally on the calculator I go 4,000 divided by 35. Pause. And I could say it decreases by 25 marriages per quarter. But the reason I round so brashly is because you saw how brashly I did my rise. And I also did my run pretty brashly as well. And pause. Alternatively, you could use Excel if you'd like it to be more accurate. So you highlight your raw data. Actually, technically you should smooth the data first, but I haven't got time to do that for this video. So, where's insert? Insert, graph, this one. Don't want that one. And this is actually a good example because there's no seasonality, so I don't need to worry about smoothing the data. But if there were seasonality, I would smooth first on Excel and add the trend line to your CMM. Right click, add trend line, linear, display equation on chart, and look at that. The coefficient in front of the X is your gradient. And we're not surprised that it's negative because it's declining, and we wouldn't even give it to 96.5. We would say it is declining at approximately 100 marriages per year. It's not quite true, is it? Some years it does decline by 100, some years it stays the same, but in a general aspect, it's decreasing at 100 marriages every year, which is quite scary for the future of our country, I believe. And pause. And as I mentioned earlier, you could actually look at this middle trend because it's opposite to, it's an unusual feature about the graph. It's going in the opposite direction to the general trend. And what you need to do is make up a small triangle, look at the rise, look at the run, and do a division. So 95 to 2005, actually 97 or 96. There's approximately 8 years, give or take. And the rise here from 21,000, just over 21,000 to just over 20 to just over 21. I'm going to call that a rise of 1,000 marriages. Gradient, rise over run, 1,000 divided by 8, it's actually approximately 120 or something. Approximately 120 marriages are increasing between the years of 96 to 2005, which is in the opposite direction of the general trend. Pause. The bit that I just did on the board there, you could have done with Excel. Highlight 96 through to 2006. Yep. And insert scatter, line graph. Get rid of this series. Delete. No seasonality, so no need to smooth. Add trend line. Display equation on the chart. Look at that. As I said, it's actually between those two seasons increasing by 120 marriages every year. And stop.